Hello again and welcome to another video on functions. This time we're going to be taking a look at operations on functions. What are the operations that we want to consider? Well, there are the four basic ones: addition, subtraction, multiplication, and division, plus another one that we're going to take a look at towards the end of this video. But for now, let us start with the basic operations. So basic operations. The basic operations, as we know, are going to be f plus g. This is addition. Then subtraction, f minus g. Subtraction. And then, of course, the remaining two basic operations, multiplication and division. So f times g and f over g. So multiplication and division. Okay. So there is no big secret on how to perform operations between functions because everything actually relies on the algebra that we have already investigated together. We're going to be looking at addition of fractions, we're going to be looking at all sorts of things, common denominator, all this algebra that we have seen will come back again when we do operations between functions. So let's do a couple of examples on this. Actually, I have a couple of very nice functions over here that we will play with. So, example 1. 2.5 stars. For those who are keeping track of this sort of thing, perform the indicated operation. Perform the indicated operations on, I'm going to give you an F and I'm going to give you a G, and we're going to play with that a little bit. My F is x plus 1 over x squared minus 4. And my g is 2 over x. Good. All right, so why don't we start with f plus g. So I'm going to use like a more formal notation here. Instead of just f plus g, I'll say f of x plus g of x. It's a little more formal, but it's the same thing as f plus g. So how do we add such functions together? Well, we have to add f, and we have to f we have to add g, 2 over x. How would we do this? How do we add two fractions like this? We've seen that in playing with the algebra before. Common denominator. So we shall have, what is the common denominator for these two fractions? We multiply them together, and then we crisscross. So x times, or x plus 1 times x plus 1, that's a plus, a smudged plus, plus 2 times x squared minus 4. Okay, let us simplify this a little bit. So FOIL, so another algebra technique that we need to use, that would be what? X squared plus x plus 2x squared minus 8. All that jazz over x times x squared minus 4. So all we got to do now is collect our like terms and conclude on the problem. So f plus g will be equal to what? x squared plus 2x squared, that is 3x squared. I only have x minus 8 left. So plus x minus 8. And that would be over the denominator. So x over x squared minus 4. And that is f plus g. That is f plus g. So again, simple common denominator thingy, and it works out. Now let's see if we can actually do subtraction. So subtraction, I would like to do f minus g this time around. F minus g is my b problem. F minus g, so the same functions. The only thing that changes is a minus in the middle. All right, so the strategy is a little bit repetitive. I apologize for that, but it'll help us drill it in. Common denominator, we multiply the two denominators, so x times x squared minus 4. The crisscross is x plus 1 times x minus the other crisscross 2 times the x squared minus 4. And we did like we did for addition, we FOIL out. So that is x squared plus x for the first bracket minus 2x squared plus 8 for the second bracket, all over x times x squared minus 4. Collect our like terms, and we're done. So this is minus x squared plus x plus 8 over x times x squared minus 4, and that's how we have subtracted g from f. Simple and similar to the addition. All right, so let us practice now on f times g. So f times g, so the c part, this time multiplication between f and the g, multiplication. Now, how do we multiply fractions? It's not the same thing as addition, subtraction, right? We know that when we multiply fractions, it's top with top, bottom with bottom. So that should be quick. So x plus 1 times 2 over x squared minus 4 times x. There isn't really a lot that one can do here, really, except perhaps write, if I want to FOIL out, another possible answer. This is okay, but this actually is FOILed out, over x3 minus 4x. And that's the multiplication of f and g. Simple enough to remember. When you multiply, it's top with top and bottom with bottom. All right, so let's do an example of division. Let us do an example of division. So d f over g. So what is that? This is x plus 1 over x squared minus 4 divided by g, which is 2 over x. All right, so here we have, yet again, an example of what we called before a complex fraction. So 1 division bar, 2 division bars, and the third division bar right here. That needs to be flipped, right? So we're going to do this. X plus 1, x squared minus 4. And this, my longest of my division bar, can be translated with this symbol, division. Should make it a little larger here. So division by the bottom function, 2 over x. So top over this, is the top divided by 2 over x. Now we flip. So x plus 1 over x squared minus 4. I'm going to change the division to a times. And I'm going to flip my fraction 2 over x becomes x over 2. And then basically I have x plus 1 times x, multiply top with top, bottom with bottom, x squared minus 4 times 2. We could put brackets here if you want. And then I can leave it like that, or I can FOIL. The two answers are perfectly equivalent. So here's one version of a potential final answer, x squared plus x over 2x2 minus 8. And that's how I would perform the division of f and g. So as you can see, nothing here is like too difficult. We just get to practice some of the algebra we have learned about handling, in this case, fractions. Good. So, all right, so example 2. Example 2 will pertain to another category, if you want, of operations on functions. So I'm going to call this evaluation of functions. Okay, what is that? Evaluation of functions is basically, the word says it, when I want to evaluate the function at a point or at another function. So it's f of something that I'm trying to evaluate. What is the answer of f of 2, f of 7, f of 0, this sort of thing. And for that, well, we already pretty much know what's going on, right? If you want to obtain f of a, if you want to obtain f evaluated at a point A, you need to do what? How do I find f of a? Basically, if I have a function and I have a point A and I want f of a, what do I need to do? I need to replace a inside f of x. That's it. Inside f of x. It's as simple as that. It's as simple as that. So let's see if we can get some examples on how this could work. Example 2, middle of the road. What did I have before? Let me have the same functions. Why not move away from a good thing when we have a good thing? So f of x is x plus 1 over x squared minus 4. And we also had g of x to be 2 over x. So let's see if we can evaluate these functions at certain point value. So find, say, f of 0. How would you actually find f of 0? Well, that's simple. We got to replace all the x's in the function by what? By 0, right? So this would be 0 plus 1, because here I had an x, so I replace it with 0, over 0 squared minus 4. And you just basically replaced all the x's you have with 0, and then you have what? 1, 0 plus 1 is 1, and 0 minus 4 is minus 4. So f of 0 is minus a quarter. F of 0 is minus a quarter. Good. What about f of 2. Let's calculate f of 2. Simple, replace x by 2 in the function. So top, 2 plus 1 over 2 squared minus 4. 2 squared minus 4. Top is 3. Bottom is, whoa, 4 minus 4, 0. What is 3 over 0, huh? The 3 over 0 is something we're going to meet very often in calculus. If you ask the calculator for 3 over 0, you are going to get an error message. You're going to have error. We don't call that error in math. Error is the language of the machine. In math, perhaps you've heard the term before, undefined. Undefined is what we call 3 over 0. Some people also call this D and E. What does D and E stand for? D and E, you know this. D and E stands for does not exist. Okay, good. Can I evaluate something else here? Maybe. Let's see if I can make some room and go over there. So, numéro 3, the third one, evaluate g of 7. How would I evaluate g of 7? Well, g of x is 2 over x. So, g of x is 2 over x. So, g of 7 is going to be 2 over 7. Let me put that in red, since it's the number a at which I evaluate my function. And there you go. That's it. It's done. 2 over 7 is my answer. Would you be able to get, for me, this one? G of w. G of w. So that's not a number. So the answer to g of w is not going to be a number. It's going to be something that is a function of the letter w. So g of x is 2 over x. So I'm going to replace x now with w. So that is equal to 2 over what? W. Yeah, it's simple as that. One last. What about f of w? What about f of w? Believe it or not, this is calculus related. What's f of w? Well, f of x is x plus 1 over x squared minus 1. We want to replace a number or a letter, same strategy. We need to replace the x with w. So in here, this x becomes w, and down there, this x becomes w. So w plus 1 over w squared minus 4. W squared minus 4. There's not much that I can do about this, really. Can't really simplify it. I guess I could factor the bottom, but I won't. So that's f of w. It's not very pretty, but it is what it is. So why this evaluation at a letter like w? Like I said, because it is actually very useful in calculus. So let's talk about a special case of function evaluation. All right. So special case of function evaluation. What is that special case? It's the case of f of x plus h. All right, so in calculus, this x plus h turns out in a lot of places. So since we're preparing for Cal, let's take a look at this. So I will need to be able, for several classes of function, I'll need to be able to evaluate what f of x plus h is. So we're going to get for this some strategy. All right, so what's going to be our strategy to find f of x plus h, this important part of the function evaluation? Step one. Replace all x's in the function. Replace all x's in the function by an open bracket. By an open bracket. What does that mean? It means that you look at the function you're given. Every time you see an x, you erase the x and you replace it with an open bracket. Okay, simple enough. And we complete this procedure with step two. Put x plus h in the open bracket. If you follow this simple and quick guideline, you will always arrive to the correct result. So, what's our strategy? You see an x, get rid of it, put an open bracket in the place of x. Once this is done, you're going to have a bunch of open brackets. So in these open brackets, all of them, you put x plus h. Example. So example 3, I guess. Example 3. Perhaps for some of you, this is 3 stars. So I'm going to label this as 3 stars. Let f of x equals x plus 1 over x squared minus 4. Period. The same f of x as before. Find f of x plus h. Find f of x plus h. All right? So, step 1. When I see an x, I erase it completely and I put an what? Open bracket. So, f of, there's an x right here. Gone. I want an open bracket in the place of x. Follow through into the function. There's an x in the numerator right here, x plus 1. You see that? That x becomes, it's gone. It's replaced with an open bracket. Plus 1. Over. There's one final x in the denominator, x squared. Gone. It's now open bracket squared minus 4. That is step 1. Did you follow this? Every single x got replaced by an open bracket. Step 2. Well, step 2. In each of my open brackets, what am I going to replace in? In each of these open brackets, I shall put x plus h. So, back up. So, step 2, f of x plus h. So let me repeat those open brackets. Plus 1, open bracket squared minus 4. And in each of these open brackets, I shall put x plus h. And I'm done. This weird expression, x plus h plus 1 over x plus h squared minus 4, this is what we call f of x plus h. Simple procedure, and if you follow this, you will never be at fault. This works all the time. All right? Let's do another example. Let's do another example. That would be example 4. Also, 3 stars. Let f of x equals root x. Find f of x plus h. Find f of x plus h. All right, so f of x is root x. F of x plus h is what? Let me apply my little baby strategy. As baby as can be, it's super efficient. I'm going to stick with it. I see an x. I replace an x with what? Open bracket. So, step one. F of, whoa, that's an x. Open bracket. I got root of, here's another x, open bracket. Okay? Step two. What do I do in step two? Put in the open bracket x plus h. So f of open bracket equal root of open bracket. And what do I put in open bracket? I put x plus h. Et voila. That's done. F of x plus h is the root of x plus h. Good. Remark, this is not the root of x plus h outside. No, 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 no. The h is inside because the x is inside the square root. Okay? So the h is inside with the x under the same square root. Good. Let us go on with b. Find f of x plus h minus f of x. So here's an operation between functions, a subtraction. What is f of x plus h minus f of x? Well, let's use our findings in the a part. F of x plus h we have found is the root of x plus h. That's too small. You probably can't read this. I'll make it a little larger. Root of x plus h minus f of x. Well, f of x is given. Minus root x. Good? Ça va? C. Simplify the expression f of x plus h minus f of x over h. All right, one last effort. F of x plus h minus f of x over h. Notice that the numerator we already calculated in b, right? F of x plus h minus f of x. In b, what did we get? Root of x plus h minus root x. So this is just root of x plus h minus root x divided by h. All right, I can do that. So this is root of x plus h minus root x over h. I am supposed to simplify this. What is your reflex when you have roots like this and they say simplify? What is your reflex? If you're thinking I got roots, then I need to use the conjugate, your reflex is excellent. I'm going to multiply top and bottom by the conjugate of the numerator, which is the same, but the middle sign shall change. So this is the root of x plus h plus root x. This is the root of x plus h plus root x. And then we FOIL. And then we FOIL. Root of x plus h times root of x plus h is x plus h. When I do the conjugate, do you remember what happens to the middle terms? What happens to the middle terms? When I do first and last and first, these will cancel. I'm not even going to bother writing them down. They always do. They always cancel. The only things left is first with first and last with last. Minus root x times root x is minus x over h times the root of x plus h plus the root of x. Yes? You still with me? Okay. Do I have some cancellations in the numerator? I believe I do. X minus x is gone. So this is just h over h root of x plus h plus root x. What happens to the h's? Well, clearly, they're gone. So the final answer here is simply going to be 1 over the root of x plus h plus root x. That's the simplification of f of x plus h minus f of x divided by h. You don't know it yet, but what we've been doing here is actually a very, very close to calculus problem. Good enough for today. We shall continue on this next time. I wish you well. You take care. Hasta la vista.